Hello boys and girls! In this episode I'm driving into all the details around rails in Factorio. We will look at tracks, trains, signals, junctions and stations. Since Factorio 2.0 you can now place tracks in 16 different directions. However, for most practical purposes only horizontal and vertical tracks are truly useful because only those can support stations and ramps for elevated rails. The other directions are handy when building out your wider network, especially in the outer regions. But at the core of your base, you really want everything neatly laid out in a clean grid. When laying tracks for good throughput, you'll want one track per direction. Signals can be placed either on the inside or outside of the track, whichever you prefer, but be consistent. I like having them on the inside as that keeps the outer edge clean. Between the two tracks I usually run a power line. My personal spacing is 4 times between the parallel tracks, but there are other workable options depending on your layout. Before we talk about signals, let's cover trains, since that directly affects signal spacing. The optimal ratio of locomotives to wagon is 1:2. You can run double-headed trains which can reverse direction and use terminus stations, but I prefer single-headed trains with 2 wagons. This simplifies refueling since there is only 1 locomotive per train to manage. Signals are what divide your track into sections or blocks. A train waits at a signal to reserve the next section of track. Adding more signals increases the maximum number of trains that can run in your network, but keep in mind, signals are only efficient if trains are rolling smoothly. Frequent braking and accelerating reduce throughput. That's why I place signals so that each section can fit exactly 1 train. No wasted space, no unnecessary stops. There are 2 types of signals: regular signals and chain signals. A regular signal allows a train to reserve the path up to the next signal. A chain signal reserves the entire path that the train wants to take until the first regular signal ahead. In practice, this means you should use chain signals before a merge, split or crossing, and regular signals after. That's the simple rule. Chain before merge or split, regular after. Now on to junctions. The simplest junction is a T-junction where trains only join or leave 1 line, avoiding any crossing. Next is a variation where a side line branches off and then rejoins the main line on the same direction. This adds 1 crossing. You can extend that to both sides, which adds another. If we look at the signal blocks, we will see that the entire junction can easily become 1 big block, which isn't ideal if you have heavy traffic. The last one is a 4-way junction or an omnidirectional cross. This type is a major bottleneck when your network is busy, so I generally avoid it for general purpose use. Instead, I prefer roundabouts, which handle flow better but take up more space and temporarily merge multiple tracks into 1. You also should not have junctions too close together so that you can at least fit 1 train with signals in between. At the end, we will look at a few junction designs using elevated rails to help reduce crossings and design a set of blueprints suitable for a megabase scale network. Up next, stations. The loading and unloading speed should match the supply and demand of that station. Ideally, you want trains waiting at the unloading station. That's a sign your supply is keeping up. I usually include a steel chest buffer for loading and unloading to help balance fluctuations. You can have loading, unloading on one side or both sides of the track, depending on your needs. Now, how many trains do you actually need? A rule of thumb. The number of trains should equal the number of stations in your schedule, including duplicates, minus 1. For example, if you have one iron ore unloading station and 2 mining stations, you can run 2 trains, because there must always be at least 1 free stations for a train to go to. Otherwise, you risk a deadlock. As you expand outward, train travel times get longer, reducing network throughput. The fix is to add more trains, which means you will also need waiting areas near your stations. You can create these by using chain signals between the waiting bays and the main signal behind the station. There are setups using train interrupts, which let you reuse the same schedule for multiple purposes. But I don't typically use those. Where I do use interrupts is for refueling. There are 2 key things to keep in mind. Use only one type of fuel, don't mix them. And after refueling, a train might get stuck, blocking others from accessing the fuel station if its destination is full. You can avoid this by adding a dedicated waiting bay near the refueling stop. It's usually only a problem for certain train types. Now back to the promised junctions. The goal is to avoid crossing lines whenever possible. You can do this by elevating one of the tracks and spreading out the station. With this approach, I can design a cloverleaf style junction that keeps trains flowing smoothly. One important thing to remember: trains always go to the nearest available station with the right name. You can manage this more precisely using circuit logic, but for now you can control it manually by limiting the number of trains per station. As your factory grows toward megabase scale, some lines will naturally get more traffic than others. To keep things flowing, build your rail network in a grid with city blocks between intersections. And every few grid sections, double up the tracks from 2 to 4 lanes. There are still more improvements to explore, especially when integrating circuit network into the rail network, but I will cover that in the circuit logistics episode. Next up, however, are space platforms. Until then, goodbye!